You know, every single day we're surrounded by packaging. We tear it open, we eat out of it, but let's be honest, have you ever really stopped to think about what that packaging is made of? And, more importantly, whether any of those materials are sneakily getting into your food? Well, today we're diving deep into the surprisingly complicated world of food contact materials.
I want you to picture this. You've got a hot, greasy, delicious pizza right in front of you. And you notice some of the ink from the inside of the lid has smudged onto the cheese. So is that colorful print something you should worry about? That one simple question, it gets right to the very heart of why food packaging is so heavily regulated. And it all boils down to one key idea.
And that big idea is migration. It sounds kind of technical, but it's really simple. It's the invisible transfer of microscopic chemicals from the packaging, the inks, the plastics, the glues, directly into the food you're about to eat. It's this tiny, unseen process that's the whole reason all these super detailed safety rules even exist. So the entire game is about controlling that transfer from the package to your plate. Every single rule we're going to look at today is designed to keep that migration below a level that's considered safe. But how on earth do you even measure something like that?
Well, the European Union puts a hard number on it. They call it the Overall Migration Limit, or OML. The limit is 10 milligrams of stuff per square decimeter of packaging. Now, a square decimeter is roughly the size of a postcard. So just imagine a postcard-sized piece of plastic wrap. The total amount of anything that's allowed to transfer from it can't weigh more than a couple grains of sand. It's tiny.
And here is the real kicker, and probably the most important thing to remember from all of this. While the goal is always safe food, the rules are not the same everywhere. The answer to the question, what's safe, changes completely depending on whether you're in Europe or the United States. And this is where things get really interesting. All right, Section 2, the blueprints. Let's break down these two very different philosophies for safety, the EU versus the US. These two approaches are just fundamentally different. Think of it this way. The EU has a safety rulebook. There's this big overarching law that says all materials have to be safe, period. Then it has specific chapters for certain materials like plastics. The US, on the other hand, uses what I like to call a VIP guest list approach. A chemical can't be used in packaging at all unless it's been pre-approved and added to the FDA's official list. If your name's not on the list, you're not getting it. Now, to go a little deeper, we need to get the lingo down. You'll hear FCM thrown around a lot. That's just any food contact material. We already met OML, the overall limit, but there's also SML, which is a specific migration limit for individual chemicals. Then you've got NIAS. These are the sneaky ones, non-intentionally added substances, things like impurities that weren't supposed to be there. And finally, the DOC, the Declaration of Compliance. That's the all-important paperwork we're going to come back to. So you'd think with all these rules, everything's covered, right? Well, not so fast. When we start talking about things like printing inks and the glues that hold boxes together, things get a little murky. It's a regulatory gray area, and that's a huge challenge because you can't make a modern package without them. Just look at how this plays out in the real world. For printing inks, the EU literally has no harmonized measure, meaning no single unified law for the entire block. It's wild. Meanwhile, the US FDA focuses on making sure adhesives are behind a functional barrier. Basically a layer that physically stops any chemicals from migrating. It's two totally different ways of tackling the exact same risk. So, what does a company in Europe do if there's no clear EU-wide rule for inks? Well, they look next door. Turns out, the incredibly detailed Swiss law, and specifically its list of approved ink substances called Annex 10, has become the unofficial gold standard. It's what the best in the business use to prove they're being safe. You see, when governments leave a regulatory gap, the industry has to step in and fill it. And this is where things like good manufacturing practices, or GMPs, become absolutely critical. Industry groups like UPA for inks and FICA for adhesives create their own super detailed guidelines, and those guidelines effectively become the rulebook everyone follows.
Which brings us to Section 4, the paper trail. Because in this whole world of regulation, knowing the rules is one thing, but proving you follow them, well, that's everything.
So remember that DOC acronym? In the EU, for materials that have specific rules, like plastics, the declaration of compliance is the key. And this isn't some friendly note. This is a mandatory legal document. Think of it as the official passport that has to travel with the material all the way down the supply chain, proving at every step that it's safe and it complies with the law.
Okay, let's make this super practical. Say you need to pick a glue for a food package. In the US, the first question is dead simple. Will it touch the food? If the answer is yes, you check one part of the regulation. If it's no, you check another part to make sure there's a good barrier. In the EU, since there's no specific law, you turn to those FEICA industry guidelines and do your own risk assessment. But look at the last step for both. Document everything, always.
So let's turn this all into a quick and dirty checklist for you. If you're working with plastics in the EU, always demand that declaration of compliance. For inks and glues, you need to write the industry GMPs directly into your contracts with suppliers. If you're in the US, you have to map every single component to an official FDA clearance. And for every single project, no matter where you are, document the intended use. What food is it for how long, and at what temperature? Because context is absolutely everything.
Let me tell you about a classic rookie mistake where this all goes wrong. It's a thing called set-off. So you print a beautiful design on the outside of your packaging, then you roll it up or stack it for transport. But the ink from the outside of one layer rubs off onto the inside food contact surface of the next layer. Uh-oh. That's a direct path for migration, and it's a perfect example of why those good manufacturing practices are so critical.
And really, this brings us to the final, most crucial point of all. Anybody can slap a food-safe label on a product. That's just marketing. What truly matters, both for safety and for the law, is having the data, the lab tests, and the documentation to prove it. That paper trail is what separates a hollow claim from verified, real-world compliance.
So as packaging gets more and more innovative and our supply chains stretch all across the globe, it leaves us with a pretty big question. We have these two powerful but very different systems for keeping our food safe. In a truly connected global market, can that split really last forever? Or are we eventually going to need a single global blueprint for what's safe to eat? That's something to chew on. Thanks for joining this explainer.